In this module, you will learn about many of the key data protection features provided by CommVault, including the protection of virtualized environments, file systems and application support, CommVault deduplication, snapshot integration through IntelliSnap, endpoint protection, plus consolidated backup and archive technologies for file systems and Exchange. We'll begin today's module with a discussion of CommVault software's capabilities surrounding protection of applications in the data center. In the last module, we provided an overview of the various components of a CommCell and a high-level view of intelligent data agents and the functionality they provide. Now, let's delve into how CommVault software protects traditional servers and applications with our intelligent data agents. In today's modern data centers, there are a wide variety of applications and operating systems to contend with. Although some of your customers may have standardized on particular operating systems and applications, when you look across your customer base, the diversity across environments can be overwhelming. Protecting these diverse environments can provide challenges for solution providers. Every operating system and application has particular nuances and methodologies to ensure that the data residing on the hosts is protected properly and can be efficiently recovered in a usable state. Discrepancies between versions of applications can also introduce problems for the protection of these applications. For example, ensuring that applications are in a consistent state at the time of protection and that the various components of the application, such as logs and data, are synchronized properly at the time of protection is not always a simple process. CommVault software has evolved over the course of many years to accommodate the protection needs our customers demand for all of the major operating systems and applications in the market by leveraging a common platform. The expertise on how to efficiently protect data across the diversity presented by today's market does not come overnight, and the approach of using point solutions to protect these environments results in complexity and greater cost for customers. For a complete list of supporting operating systems and applications, please visit documentation.commvault.com. In the next few slides, we'll provide an overview of how CommVault protects a handful of these key applications to provide you a basic understanding of how solution-based protection of applications works. Let's start by looking at how CommVault software provides unified protection and management of Exchange data in an enterprise. The CommVault Exchange Mailbox Agent will be covered in more depth later in this module, but for sake of a brief introduction, the CommVault Exchange Mailbox Agent helps to protect, archive, index, and retain messages from a single interface that provides powerful user-level control through a flexible, policy-based architecture. IntelliSnap, as you will learn later in the module, allows CommVault software to integrate with hardware arrays and execute and manage snapshots. This capability, integrated with our Exchange protection, provides rapid, consistent point-in-time recovery for Exchange data. The Exchange Database iData Agent allows organizations to protect information stores, public folder stores, and transaction logs in both standalone and DAG environments. The Exchange Mailbox Classic Agent protects individual mailboxes to allow for quick retrieval of messages and attachments. This also facilitates the restore of entire mailboxes without requiring an entire Exchange database restore. The Exchange Public Folder Agent backs up public folders for quick retrieval of shared data between Exchange users, such as group documents, messages, attachments, and calendars. And finally, you can recover messages from an offline copy of an Exchange database. Depending on the backup method being utilized, message-level recovery can, in most cases, be performed without restoring the entire Exchange database offline first. CommVault also provides a complete backup and recovery solution for Microsoft SQL. Database backup dump files are risky and inefficient. Instead, with the CommVault Microsoft SQL iData Agent, you can read and write database and log backup data directly to and from the CommVault Content Store. Automatic discovery is a feature that lets you protect newly created databases automatically without any admin intervention. Transaction logs can also be protected automatically when needed rather than on a fixed schedule. Automatic backup chain management can automatically detect inconsistency in the backup chain and respond accordingly. The required database and log backups are automatically restored and rolled forward to the desired point in time and database state. IntelliSnap creates nearly instantaneous recovery points via a broad number of hardware vendors' storage array snapshots. Recoveries can be performed in seconds with snapshot revert. CommVault supports full clustering options, including full integration with SQL Always On. Finally, CommVault supports legacy SQL versions from 2005 to the most current offerings, as well as restores from legacy to modern platforms. When we look at the protection of database environments, it is important to understand the various components within a database solution which require protection. Here, let's review the structure of SharePoint environments and how they are protected. A typical SharePoint environment, also known as a SharePoint farm, is composed of numerous elements. The first layer is comprised of web applications. The second houses search and other application services. The third layer consists of SQL servers, which may be clustered. CommVault software provides the capability to protect all of these layers and to ensure consistency during protection to ensure valid recovery. The web application layer is protected with SharePoint-specific iData agents. Research and application layers are protected with standard CommVault file system agents. And the SQL layer is protected with SQL iData agents and potentially clustered file system agents. Here are some of the key capabilities provided with CommVault software SharePoint protection. Full fidelity backup and recovery refers to the capability with document-level backups that allows the capture of system-oriented metadata based on parameters such as modified by or version information, so that this backed up information can be brought back in the state it was at the time of the backup. CommVault software offers multiple protection options for SharePoint in order to meet an organization's use case requirements. This includes the capability to back up entire SharePoint farms, to back up at a document level, or to protect at a site collection level. New in version 11 of CommVault is the SharePoint Farm Master Client that provides simplified administration for complete backup and disaster recovery of a full SharePoint environment from a single pseudo client. By leveraging IntelliSnap technology, generating a snapshot of the content databases allows for faster backups of the SharePoint data. By using the offline browse and IntelliSnap feature, the same granularity of data can be recovered quickly from a snapshot. As depicted in the last slide, CommVault provides comprehensive protection of all entities of a SharePoint environment. Lastly, CommVault content database backups are fully aware of remote blob storage and protect RBS blobs along with the databases regardless of the backup streaming method. Although this only highlights a few of the key features of CommVault software integration with SharePoint, it does exemplify the scope and depth of the integration that CommVault software provides for SharePoint. The last database we will discuss here is Oracle. Oracle is notorious for the complexity associated with its protection, and there are a wide variety of implementation methods and third-party tools leveraged in many Oracle implementations that further complicate matters. By leveraging CommVault software and the years of experience CommVault has in protecting advanced database environments, much of the complexity associated with Oracle protection can be removed. Our software has the intelligence to know what needs to be protected and when, and orchestrates the protection of these various components to ensure application-consistent recoverability. In looking at how CommVault software integrates with Oracle, it is useful to envision an architecture where the Oracle Database Administrator will still be able to leverage the tools he or she is familiar with and manage their databases without significant operational change. From a DBA perspective, all of the tools they are used to leveraging, including items such as Oracle Enterprise Manager, Control-M, RMAN command line scripts, and cron jobs, can be leveraged as they always have. The backup administrator will have visibility into the CommVault components, including the core infrastructure as well as the Oracle iData agent. By leveraging this type of structure, the best of both worlds are achieved in that DBAs are not negatively impacted by the injection of CommVault software in the environment, while the organization is provided with significant benefit over database dumps, including the reduction in infrastructure and improved governance and management of data in the environment. To provide a bit more detail, CommVault software offers complete protection of the entire Oracle database and provides the automatic discovery of Oracle instances with granular backup and recovery of specific data files and logs. There is minimal impact to database operations, and CommVault provides simplified and automated creation of RMAN scripts. And CommVault provides deep integration to address the myriad of Oracle technologies and implementations available, including support for Oracle RAC, support of clustered file systems, ROD device support, and backup flash recovery, and Oracle Grid Control initiated backups. And of course, by implementing CommVault software for their Oracle environments, organizations gain the benefits that are shared across CommVault software protected environments, including source-side and target-based deduplication, policy-based management, IntelliSnap support, sharing and consolidation of infrastructure, and much more efficient job management and reporting capabilities. Now let's review some of the key concepts you have already learned about. Drag the correct term to match the image that depicts it. When you are done, click Submit to continue. Note that not all of the terms may be used. To touch on a couple of other relevant technologies surrounding CommVault software data protection capabilities, Grid Store technology is a CommVault software capability that provides resiliency and load balancing in organizations. At a high level, Grid Store allows for creation of alternate data paths in an environment, which may route data from a client to an alternate media agent or route data to alternate storage. In the event that a data path becomes unavailable, data could be routed over the alternative path, preserving operations. Designs can also be created that leverage Grid Store to maximize resource utilization and load balance between data paths when required. Encrypting data is an essential part of data protection, especially when data is being placed on removable media. If a tape is stolen with sensitive information on it, the information on that tape may be compromised and cause significant security risks for an organization. CommVault software offers 3 methods to encrypt data. Inline encryption will encrypt data during the backup job. Offline encryption, which encrypts backup data while being copied to secondary copies. Or hardware encryption using LTO4 or higher type drives. Inline and offline encryption is software-based. Inline encryption can be performed on the client or media agent. Offline encryption will be performed on the media agent. CommVault software supports a wide variety of encryption algorithms, as depicted in this table, to ensure security levels are obtainable regardless of the level of confidentiality required. Finally, you can now protect CommVault software encryption keys with a third-party software, SafeNet, before storing the keys in the CommServe database. Vault Tracker functionality can be leveraged in scenarios when media is being moved off-site to allow organizations to track and manage that removal media in a more efficient fashion. The core Vault Tracker functionality provides basic capabilities to automate the process of exporting, tracking, and knowing when media must be returned and recycled. Vault Tracker Enterprise is a special license that provides these functionalities for environments tracking media across several locations, and include more advanced capabilities for those organizations which require them, including more advanced filtering and export functionalities, and integration with off-site tape vaulting organization systems. Now let's delve into one of the key functionalities that applies for both the protection and management of data in CommVault software environments, our robust deduplication capabilities. Let's start by discussing dedupe ratios. It's an age-old argument and one you will almost certainly come across in your sales campaigns. Here's why it's largely irrelevant to your customers and how you can take the higher ground. All deduplication numbers are created in a vacuum. To achieve the highest dedupe ratios, what do? The full backup ratio over incremental or differential backups needs to increase. That, of course, affects the backup window, as traditional full backups are orders of magnitude longer than an incremental or differential backup. In many cases, to fit a full backup of all of your data into your ever-shrinking backup window, you back up less data, exposing yourself to data loss. So let's really talk about what these numbers mean. What is the true difference between 8-to-1 and 20-to-1 deduplication? 8-to-1 is 87.5% efficiency. 20-to-1 is 95% efficiency, a difference of 7.5%. With today's data sizes, what does 7.5% represent? 7.5% of 10 terabytes is 750 gigabytes, with the cost of storage from some cloud storage vendors at less than 2 cents per month. So for an extra few dollars of actual disk space, the customer is considering spending tens of thousands of dollars on a box and on maintenance, that will compress the data and allow for long retention times. Vendors of these boxes will tell the customer that they can store years of data on the box. On average, 95% of all restores from backup are done on data that is 24 to 48 hours old. The need to store data on expensive disk for a long period of time is a waste of money and other resources. Given that there are many different nomenclatures used in the market surrounding deduplication, let's start by exploring the processes that CommVault software undertakes when deduplicating data. Here, we'll examine the core processes regardless of where these processes are taking place in a comm cell. We start out with a data stream. CommVault software first compresses the data stream using traditional methodologies. Then it segments the data stream into identifiable blocks. A hashing process is performed against these blocks, which provides each block with a unique signature that can be leveraged for comparison purposes. These hashes, or signatures, are then compared to a database that has registered the hashes of data that has been stored in previous operations. Lastly, only the blocks of data that have been identified as unique through the lookup process are then written to the storage target. Notation of these blocks and their locations are also appended to the deduplication database for future reference. In this module, we will cover a number of key areas to help you understand CommVault deduplication and the benefits that it delivers. Let's begin by discussing source-side and target-side deduplication. Source-side deduplication, which is also commonly known as client-side dedupe, leverages a client-based disk cache known as a source-side deduplication database, which contains the signatures for the data blocks relative to that particular client. With source-side deduplication, redundant data is identified at the client and is reduced prior to the network transmission of that data. Target-side deduplication, on the other hand, conducts the comparison process via a deduplication database resident on a media agent prior to writing the data to the content store. This is similar in fashion to many deduplication appliances which bundle a server, software, and storage in a single target device. It is key to note that with CommVault software, customers do not have to make an all-or-nothing decision when it comes to the type of deduplication appropriate in their environment. Both source and target-side deduplication may be designed in a customer environment to suit their needs. For example, if there is a 24/7 database server that is under heavy load and per organizational requirements may not have additional processes run on it, a policy could be created to leverage target-side deduplication for this particular client. The customer would still gain the benefit of reduced storage consumption for the backup without impacting the load on the production server. When we discuss the deduplication database, we are referring to a database where hashes, also known as signatures, are stored and compared to determine if particular blocks of data are unique. The deduplication database is typically located on the media agent assigned to movement of a particular dataset. In the case of source-side deduplication, a client-specific table is located on a disk cache within that client. Each storage policy has a deduplication database associated with it, and that database maintains all the signature hash records for the storage policy. CommVault follows a similar methodology to our distributed index functionality discussed in Module 2, with the distribution of deduplication record information. When a particular piece of data is written to the storage target, the signature and location information relative to that object or job is also stored with it. This allows us to only use the deduplication database for check-in or lookup processes only. The deduplication database is not required to restore any particular piece of data. That said, the deduplication database is protected in order to minimize disruption or loss of deduplication efficiencies in the case the database becomes unavailable. There are numerous methods to protect the dedupe database, but by default an automatic backup job is performed on a regular basis. As was discussed in an earlier module, dash copy is a technology that enables the transmission of data in its deduplicated, reduced form factor between media agents. This reduction in bandwidth consumption facilitates disaster recovery and also eliminates the need for vendor-specific array replication for disaster recovery purposes. To expand our discussion of dash copy, some other items of note are as follows. Dash copy furthers the resiliency of environments providing capabilities such as bandwidth throttling, HTTPS security, and job-based confirmation. Also important to note is the fact that if a network line becomes unavailable during the course of a dash copy operation, the job will be resumed at the point where it left off as opposed to having to start the entire dash copy operation over. Dash copy eliminates the need for rehydration of data and provides a fast, asynchronous copy movement of just unique blocks to the secondary target. There are two ways in which it can be configured. On fast networks, LAN mode may be leveraged to read, compare, and move data in the most efficient manner. For slower or less reliable networks, WAN mode provides caching and may be utilized to minimize network lookups. Dash copy also provides the robust management capabilities which it inherited from the mature aux copy functionality upon which it is based. This includes the capability to maintain different retention periods for copies, control over job aging, and robust reporting capabilities. CommVault software also provides a global deduplication capability, wherein multiple storage policies may be tied together using a global deduplication engine. This allows customers to collapse wider groups of common data into a global pool to maximize the level of efficiency with deduplication. It also provides customers a great deal of flexibility and allows them to design fan-in scenarios to maximize the utilization of deduplication disk libraries. A global deduplication engine can span secondary sets of dash copies in a single data center repository as depicted in this diagram. In the last module, we discussed the concept of synthetic full backups and the benefit that can be derived by leveraging synthetic fulls. That said, with many implementations, particularly with appliance-based deduplication solutions, synthetic full backups can prove to be highly problematic. This is due to the fact that when a synthetic full baseline generation operation is performed, the data to recreate the synthetic full is being pulled from the relatively slow backup disk, and the processing on the server component performing the operation can be taxing. The actual amount of net new data that needs to be written to the disk is minimal, but due to architecture restrictions, a synthetic full operation can run more than 50% slower than a regular full backup with traditional technologies. CommVault software counters these deficiencies by leveraging synthetic dash full operations. In a synthetic full operation, the media agent is aware of the indexing structure provided and does not require rehydration and re-deduplication of the data. During the operation, reference counts and metadata are written to disk to denote the changes that have been made to the dataset. The net effect of the synthetic dash full operation is that the benefits of a synthetic full backup may be derived without the performance impact. Compared to a traditional method of deduplication, The synthetic dash-full operation reduces jobs from several hours down to minutes. Another deduplication concept that we will discuss is that of partitioned mode. Deduplication partitioned mode allows an organization to federate a set of deduplication partitions into one master grid, using multiple media agents to host individual physical portions of a larger logical deduplication database. The net effect of partitioned deduplication allows customers to scale out their deduplication store to unprecedented capacity levels. CommVault next-generation software further increases scale by 100% over version 10, as it now supports either 2 to a maximum of 4 deduplication nodes per grid. 3 nodes is currently not supported. The following illustrates the process of a 2-node deduplication partitioned mode grid in action. To start, clients select a data mover, media agent, to send data to based on a grid store policy. Let's look at a data stream creation by a client in this group, which is hashed during the initial client-side operations. Data mover uses an internal algorithm to select which partition to perform the signature lookup against. If the partition selected is on the other media agent, lookup is performed over the network. The algorithm ensures multiple occurrences of the same block are always looked up against the same partition. If a data block already exists, references are updated in the selected partition and metadata is updated on the mount path the data mover has access to. If the data block is new, the signatures are updated in the selected partition and the data block is written on the mount path the data mover has write access to. Repeat similar process on other clients that select a different data mover using grid store. The data is always written by the selected data mover, although signature lookup could occur on either partition. Per block movement. This partitioned deduplication configuration allows CommVault software the ability to scale and accommodate large datasets when required. The penultimate deduplication topic we will cover is extended mode. A deduplication extended mode configuration is when a single media agent hosts multiple deduplication databases or DDBs. In most use cases, a media agent will host one physical deduplication or global deduplication database. However, it may be beneficial for a single media agent to host an additional DDB in certain scenarios. For example, with a single media agent, you may wish to serve primary backup data and act as a secondary replica target for a media agent at a different site. Some long-term data retention requirements can be met. For example, a short-term primary copy and a longer-term secondary copy that is closed off or sealed every year. We are all aware of the dreaded big data challenges, especially with unstructured data. Extended mode can provide protection of large amounts of unstructured data with shorter retention requirements. Finally, an extended mode media agent can be a fan-in target from 2 or more DDB media agents managing primary copies. Automatic backup chain management can automatically detect inconsistency in the backup chain and respond accordingly. The required database and log backups are automatically restored and rolled forward to the desired point in time and database state. The final topic we will cover on deduplication is a combination of the 2 previous concepts we discussed. You may combine partitioned mode with extended mode. This is accomplished by configuring 2 to 4 media agents in a grid with 2 DDBs per media agent. This configuration is called Partitioned Extended Mode. The following illustration depicts a 2-node partitioned mode configuration also running in extended mode. The 2 grids are configured as both a primary backup target for local data and as a secondary replica dash copy target for the alternate grid. At this point in the module, let's shift gears and discuss CommVault Software's IntelliSnap functionality. The benefits of snapshots are widely recognized in the market. Snapshots can provide a high-performance point-in-time copy of data on a particular volume or storage array, usually with a minimal storage footprint. Some of the perceived benefits of snapshots include their storage efficiency, the speed by which snapshots can be created, their accessibility, the improvement that can be seen in recovery point and time objectives, and in minimization of operational disruption. That said, the adoption of snapshot technology is oftentimes less than the original expectations for customers. This is due to numerous factors, including the complexity associated with the need for multiple tools to conduct snapshot operations, which is compounded in heterogeneous environments. In order to properly prepare applications and ensure that a crash and application-consistent copy is generated, scripts are often required. Likewise, in order to process the snapshot and conduct operations such as backup off that snapshot copy, scripts are usually mandatory. The I/O impact on production volumes is often found to be unacceptable in environments, and the challenges in integrating snapshots into a cohesive data management strategy oftentimes discourage adoption. The solution that CommVault software delivers is known as IntelliSnap technology. IntelliSnap is a software functionality built into the CommVault suite that controls and manages snapshot functionality across a wide variety of hardware storage platforms, allowing users to integrate and utilize snapshots as an effective tool in a comprehensive data and information management solution. IntelliSnap integrates with a wide variety of hardware storage arrays and leverages the APIs for the arrays in order to manage and control the snapshot process. By combining CommVault's deep experience with application and data protection with the power of hardware snapshots, customers are able to leverage snapshots in a much more effective manner. Some of the key benefits derived when leveraging IntelliSnap functionality include centralized configuration and reporting of all aspects of data protection across the environment, the capability to use a single policy for the entire lifecycle of a dataset, and the elimination of scripting and simplification of snapshot operations through the CommCell console GUI. As depicted here, IntelliSnap supports a wide variety of hardware platforms and applications in the market. For the latest supported devices, as well as for detail on application support, please visit the CommVault documentation website at documentation.commvault.com. We will delve into the specifics of IntelliSnap mechanics in later training, but at a high level, the media agent interfaces with the storage array to control the snapshot process. Scheduling is handled at the CommServe level, and at pre-specified times, the media agent will initiate snapshots on the array via the array APIs. The media agent may be configured to mount a particular snapshot for further processing options. The snapshot may be cataloged, the data within deduplicated, and moved to whatever tier of storage is designated in the policy. The entire process is orchestrated via the CommCell console GUI without the need for scripting. Storage engineers are increasingly looking toward a fairly common design methodology when it comes to snapshot creation and retention. While this design has been propagated significantly by storage vendors due to the increased disk consumption in a snapshot repository, the design presents several merits, including reduced RPO windows while keeping the total snapshot count minimized. While this depiction is simplified, storage engineers today are looking to create hourly snapshots as rollback points during the production timeframe. Once that window is complete, snapshots would be retained for traditional recovery purposes. In this depiction, snapshots are being created every 2 hours from 8 a.m. to 8 p.m., with the 6 p.m. snapshot being retained for 7 days, and those weekly snapshots being retained for 4 weeks. In previous versions of CommVault software, maintaining this type of structure was difficult. Using days and cycles, each snap had to be maintained for a minimum of 1 day. While the first or last snap of the day could be retained for extended retention, snaps created between the first and last of the day could not be picked up for extended retention. Another topic of note is IntelliSnap replication support. Although we do not cover the full depth of technical detail in this particular course, it is worth understanding the benefits and capabilities of this technology. Industry studies show that customers are still heavily invested in production storage and are turning to the adoption of multiple storage replication technologies to protect workloads and critical applications in a consistent fashion and moreover prevent the loss of data held on centralized storage. There are also the added pressures of meeting more demanding recovery point and recovery time objectives, improving storage utilization, and minimizing administrative overheads. CommVault has long been providing the replication of NetApp-based snapshots through its integration with NetApp SnapVault and SnapMirror technologies. CommVault next-generation software now introduces an IntelliSnap open replication framework. The key difference here is that CommVault becomes replication aware and utilizes existing relationships in the vendor asynchronous or synchronous replication software. From here, CommVault can create and manage consistent clone or snapshot copies in the production and disaster recovery site. CommVault currently supports EMC VMAX storage running SRDF replication and HDS block-level arrays running Hitachi TrueCopy and Hitachi Universal Replicator. Through this new open framework, CommVault is planning to add multiple new hardware replication expansions throughout the waves of version 11. Also, as the depth of IntelliSnap integration varies across array vendors, it is also recommended to check the latest supported platforms on the CommVault documentation website at documentation.commvault.com. Now let's discuss how CommVault software protects virtualized cloud environments with our Virtual Server Agent, or VSA. The movement of the industry toward virtualization in the data center has been well documented. However, newer trends around cloud and IT as a utility have not only blurred the data center's role, but have also driven wider adoption of all virtualization technologies: server, storage, and networking. This has also led to a new breed of hyper-converged technologies cropping up and gaining momentum. This move has meant that protection, manageability, and dynamic reaction to change have become high-priority business items that need to be addressed. This is manifesting itself in a number of ways. Customers migrating some or all of their applications and assets to the cloud. Solutions providers are developing new models and services to accommodate those demands, and customers are taking advantage of technologies that enable more effective provision of services to their internal customers in an attempt to accommodate demand and maintain their relevance. The benefits from virtualization now extend well beyond the benefits of cost savings through resource consolidation and reduction in operational overhead. Businesses now see that many applications can realize improvements in availability, reliability, and even performance by running in a public, private, or hybrid cloud. As a result of this shift, many organizations are looking to rapidly scale out their virtual infrastructure and adoption of the cloud to encompass most, if not all, their entire data center. The CommVault Virtual Server Agent, or VSA, provides a policy-based protection, recovery, and management mechanism for different virtualization platforms. The CommVault VSA currently supports core data protection and recovery operations for the following hypervisors: VMware, Microsoft Hyper-V, Xen Server, Nutanix Acropolis, and Red Hat Enterprise Virtualization. CommVault also supports the provisioning and lifecycle management of VMs hosted in Amazon and Microsoft Azure clouds. As you will discover later, it is also possible to convert VMware and Hyper-V VMs to Azure and Amazon clouds. We will cover the core functionality and integration with each hypervisor in the following slides. As the functionality does differ between hypervisors, it is always recommended to check the latest functions and supportability on the CommVault documentation website at documentation.commvault.com. Let's first take a look at CommVault's highly mature 5th generation solution for VMware and Hyper-V. It goes far beyond many solutions which focus only on the core backup recovery options. The left box highlights our core backup recovery capabilities, including single image backup, the capability to recover full virtual machines or at a granular file level, the ability to conduct an incremental forever backups based on change block tracking, and the capability to filter VMs or disks in the protection process. The central box highlights some of our more unique data protection capabilities. This includes the capability to load balance across proxies for resiliency, the capability to leverage IntelliSnap to protect large VM environments at scale, and our capability to leverage our application protection capabilities within VMs. The right box details differentiators in building dynamic cloud environments. Features like auto-classification and conversion to Azure and AWS make CommVault the ideal product for dynamic virtualized data centers. Some of these features, including VM provisioning and management, will be detailed in a later module. We will cover off on a few of these functions in more detail momentarily. Depending on customers' requirements, there are multiple designs which the virtual server agent may operate under. With VMware, the virtual server agent cannot be installed on the physical ESX servers. The 3 methods to deploy the VSA agent will be SAN transportation mode, where the VSA agent will be installed on a physical proxy with direct access to the VMware snapshots on the data store, hot add mode, where the VSA will be installed on a virtual proxy on the ESX host, network block device, or NBD mode, where the VSA agent will be installed on a physical proxy and virtual machines will be backed up over the network. Additionally, hardware snapshots can also be used with the virtual server agent by using the CommVault IntelliSnap feature. IntelliSnap can be configured for supported hardware arrays. For Hyper-V, the VSA agent can be installed on a standalone Hyper-V server or a node in a Hyper-V cluster. You may deploy the VSA on multiple nodes for load balancing and improving the backup and restore performance. On Windows 2012 R2 deployments, a Hyper-V node with the VSA installed as a proxy can back up any VMs in the same cluster providing they reside on a clustered shared volumes storage. As was mentioned, by combining the power of the virtual server agent with CommVault IntelliSnap functionality, very large virtual environments can be protected in a highly efficient manner. By snapping a data store within a virtual environment for a protection copy, then conducting any processing on the snapshot as opposed to the live production volume, overhead on the virtual machines can be minimized. VSA with IntelliSnap functionality is supported for both VMware and Hyper-V environments. By default, IntelliSnap backups are OS and application consistent. However, it may be desirable in certain situations to provide a snapshot that is crash consistent only and that does not engage Microsoft VSS at a host level. This option could be useful for cloud service providers that are looking to offer a high level of protection to its customers that operate below the OS layer. One key functionality that CommVault software provides for virtualized environments is our capability to automatically discover new virtual machines that require protection based on specific criteria. This is very useful in dynamic virtual environments where virtual machines are frequently added or removed. Rules can be set based on any number of criteria or affinities to identify virtual machines and roll them into specific storage policies. Criteria can be items such as naming convention, virtual machines of a specific operating system, based on a specific data store, or many others, including machines associated with a specific hypervisor, DNS hostname, resource pool, within a specific folder, tied to a specific VApp, specific cluster, or a specific data center. These rules can also be combined and nested for drill-down purposes. Also, CommVault has added some additional enhanced targeting options in version 11, allowing you to automatically select virtual machines based on their power state, notes, and in VMware only, custom attributes and vCenter annotations. These advanced targeting options provide enhanced flexibility and further assurance that all VMs are protected even when not specifically targeted by other rules. Historically, finding the owner of a virtual machine required manual effort or the creation of some kind of script. In CommVault version 11 with VMware, the discovery phase can be configured to automatically check for capabilities in vCenter and that the associated user or user group also exists in the CommCell interface. It will then automatically assign the user or user group as the VM owner in the client computer group properties so they can manage their own VMs without any admin intervention. The version 11 Virtual Server Protection Agent provides enhanced inbuilt intelligent proxy teaming for failover and load balancing. First off, load balancing looks at the size of the proxy server and its available resources and then dynamically distributes VM protection and streams to each of the available proxies. This feature is also multi-job aware, which means the VSA looks across all jobs running on all proxies to make more intelligent decisions. As each VM needs to be protected, the proxies will coordinate amongst themselves and determine which is going to be the best proxy to process the VM. Larger VMs are prioritized first to prevent stragglers at the end of the job. The VSA will also evaluate the CPU and memory resources available on each proxy before allocating the VM, ensuring the proxies with more resources do a larger amount of work. This is accomplished by creating what is termed as a pseudo client. You can create a virtualization client with a single proxy computer or with multiple proxies. Creating virtualization clients with multiple proxies is useful for the following scenarios. A vCenter has a large number of virtual machines and you want to perform parallel backups. You want to use a specific transport mode to perform network-optimized backups. You want to use multiple streams to increase data transfer speed during the backup. Or one of the proxies may become unavailable during the backup operation. This functionality provides a number of benefits, including more efficient use of resources, faster completion of operations, assurance that the loss of one VSA does not impact data protection operations, and enhanced scalability. The great news is that this is not just limited to VMware. The same logic applies to all hypervisors CommVault currently supports. This is also important for MSPs and cloud environments looking to provide backup as a service capability for their customers. The functionality allows you to separate protection policies from the backup infrastructure. The VSA also provides multiple restore and recovery options. Restore of individual files and folders, entire volumes, full virtual machines, or full virtual machines out of place may be conducted depending on the recovery requirement. Now let's cover the CommVault Live Recovery functionality with the VSA. On the left, we have some of the traditional VSA mechanics, and on the right, the integrated CommVault software functionality that you are hopefully now more familiar with. We should not overlook either of these two aspects, especially when we consider what competitors are offering, specifically the niche virtualization players. Live Recovery functionality opens the lid on the CommVault Content Store, where we can gain seamless access into the protection copies and start repurposing them on the fly to meet a wide range of recovery and access use cases. Now let's look high level at the live recovery methodologies available in the product today. The live recovery features are available for VMware only today and will be rolled in for Hyper-V through future waves of the product. First up, we have the live recovery feature. This allows us to break open a backup or snapshot copy of a virtual machine and recover individual files. This feature provides extended support for various file system types. Use this feature to reduce backup times without sacrificing the capability to recover individual files. Second, we have live recovery for virtual machines. This feature provides the ability to start a virtual machine almost instantaneously while recovering it in the background. This provides an artificially enhanced RTO, as we do not have to wait for the full recovery operation to complete before accessing the virtual machine. Next up, we have Live Mount. With Live Mount, you can power up virtual machines directly from the backup copy without having to restore it or commit any changes. This allows access to the virtual machine for validation purposes or application-level recovery via the provided mining tools. And lastly, we have Live Sync. Live Sync takes changed blocks from our standard VSA protection copy and overlays those blocks to a warm standby VM at an alternate location, thereby providing VM-level replication. Live Sync can be used to create and maintain warm recovery sites for virtual machines running critical business applications. Restoring virtual machines with live recovery is currently supported with VMware only. The Backup Media Agent includes a proprietary 3D file system component which exposes the backed up data as an NFS export that gets mounted to the destination ESXi host. A modification to the associated VMware VMX file indicates that writes can now be made to the newly mounted NFS data store. Once the data store is accessible, the VM can be powered on directly from the backup copy and accessed during this time. Changes made to the VM are persistent and are reconciled once the recovery process has been completed. Now let's look at the live mount process for VMware. The exposure of the backup copy as an NFS export is just like the live recovery process we covered previously. However, live mount first requires a VM provisioning policy to be created by the administrator. The provisioning policy specifies the total number of VMs that can be live mounted, how long live mounted VMs can run, and the resources that are dedicated for live mounts. Essentially, this policy defines limits to the impact that live mount operations can have on the operating environment. Unlike live recovery, changes made to the virtual machine once it has been powered on are non-persistent, meaning the backup copy remains unaltered. Remember, live mount is designed to power on VMs for use cases requiring only a short period of access. A cleanup process on the ESX server is performed once the live-mounted virtual machine has been expired. The expiration is based on the decommission setting in the live mount policy. The VM can also be powered down and deleted using the web console. Now let's look a bit closer at the LiveSync feature. LiveSync enables incremental replication from a backup of a virtual machine, source VM, to a synced copy in the virtual machine, destination VM. The LiveSync operation opens the destination VM and applies changes from the source VM backups since the last sync point. LiveSync offers the following benefits. Backups capture virtual machine data in a single pass, and LiveSync runs on the backup infrastructure so the impact to the production servers is minimized. LiveSync is hardware agnostic. There is no need to reproduce the original hardware environment at the disaster recovery site. Automated validation and the ability to specify new network connections at the recovery site ensure that startup time is minimized. The Test Boot VM option verifies that VMs are ready for use in the event of a disaster. Planned failover tests the failover process with the latest capture of VM data, and unplanned failover is used in the event that the primary site is unavailable. This option disables LiveSync and powers up the destination VM at the DR site with the appropriate network connections and IP addresses. And finally, deduplication and compression reduces the amount of data that needs to be transferred over the WAN. The CommVault web console can be used to recover a virtual machine or files from a virtual machine by their owners. Users can restore small files and folders to a virtual machine that they own without requiring that the virtual server agent be installed on the destination VM. The VMs are accessed via the My Data link on the web console and then by selecting the VM's link. From the Show Details action, the VM can be recovered, or the user can select files to restore. You will also notice some VM management options, but don't worry, we will cover these in a later module. The live mount operation is also available from here. As we discussed earlier, customers are rapidly adopting a cloud strategy in some capacity. We have just learned about the many benefits of protecting both VMware and Hyper-V with CommVault Virtual Server Agent. However, the benefits do not stop there. As customers begin their journey to the cloud, CommVault has developed a virtual machine conversion mechanism that can recover both VMware and Hyper-V VMs to Microsoft Azure or Amazon instances in the cloud. This enables customers to migrate workloads, provide disaster recovery services, and spin up VMs for test and development purposes on demand. With cloud compute becoming more heavily utilized, some companies now have a majority of their infrastructure in public cloud offerings. Cloud is no longer only a storage target or a cold DR site. It is an extension of your data center. Perhaps it is your data center. CommVault software has the flexibility to adapt and grow with your cloud infrastructure. Completely cloud infrastructures are supported, as well as hybrid approaches. CommVault software can auto-detect and protect workloads, allowing a local copy to be kept and then sending a duplicated copy to the cloud for DR. Perhaps your workload is completely in the cloud. The flexibility of CommVault software will allow the workload to be protected in the cloud, but retain a backup copy outside the cloud as well. This outside copy could be located on premises, in another geographical region, another cloud provider, or even a managed services site. CommVault software can grow with your cloud strategy and allow ease of data protection along the way. All of this is managed through the single CommVault solution. CommVault software can grow with your cloud strategy and allow ease of data protection along the way. VirtualizeMe leverages CommVault software's one-touch capabilities to quickly create a VMware or Hyper-V virtual machine image from a standard full system backup. This can be useful for physical to virtual migration as well as automated DR testing. Some of the benefits of this technology include the capability to perform off-host operations such as dev test, analytics, and DR testing while still retaining the original physical client in place. It also helps to minimize many of the challenges associated with bare metal recovery and the complex image management associated with it. In version 11 of CommVault software, it is now possible to perform data protection and recovery operations of virtual machines deployed on Red Hat Enterprise Virtualization, or REV. The CommVault Virtual Server Agent must be installed on a Windows or Linux virtual machine running under the REV data center that contains the virtual machines to be protected. The VM containing the VSA performs the proxy role, not dissimilar to the hot add configuration in VMware. CommVault integration is now provided for Nutanix AHV in addition to VMware and Hyper-V. VM protection for Nutanix Acropolis Hypervisor leverages the Virtual Server Agent, or VSA, to perform backups of VMs running on Nutanix infrastructure. One or more proxy VMs must be deployed inside the Nutanix cluster to facilitate coordination and backup of VM data. AHV backups work in a similar fashion to VMware hot add backups. Based on the customer content rules, CommVault will first discover the virtual machines which are to be protected. Next, those virtual machines will be placed in a Nutanix protection domain, which is the framework governing data protection on the Nutanix platform. Next, VM snapshots are initiated for the virtual machines, which allow access to the VM data in a read-only mode. Disks for the VMs to be protected will be mounted to the Virtual Server Agent proxy, and the data will be accessed as if it were a local disk. Now let's discuss CommVault's block-level backup functionality. Let's talk about redefining a fundamental use case, backup. Traditional streaming, even with incremental forever and synthetic full backups, is sometimes not enough. Let's talk about a revolutionary block-level backup, or BLB, method. If we look at the traditional backup operations, we have to scan the file system, copy the data with deduplication, and then index it. With incremental, we see an improvement in these operations that can produce some significant time benefits. It's a tried and true methodology that is employed the world over. Now let's take a look at the new block-level backup. Most people are familiar with the incremental forever approach utilizing dash fulls. Well, this extends beyond that. This integration is provided for Windows, Unix, and Linux file systems, MySQL, and PostgreSQL protection options today, and CommVault plans to extend this in the near future. Since it's only tracking the blocks, the scan time is tremendously reduced, and the protection operation is different since it is only looking at the blocks and tracking those changes. Incremental protection is sped up. Since the block changes are being tracked, it only needs to send those. This is great in systems with both large amounts of small files and files that are large. We no longer have to open the full file to find the changed data. We just send the blocks. Of course, deduplication is still in use, but now the load is calculated differently. This allows for more frequent recovery points to be taken during the day, something that was typically only reserved for hardware snapshots in the past. Additionally, it produces a 3 to 10 times improvement in speed and a 90% reduction on host impact. Now let's have a look at CommVault OnePass functionality. In traditional data management, processes such as the protection, archiving, and reporting of unstructured data have typically been conducted as 3 distinct processes, each of which requires some form of a scan phase, a collect or selection phase, and a phase to transfer data. As datasets have grown increasingly large, the capability to conduct multiple processes for a single dataset has become increasingly challenging. In order to contend with the massive datasets that are emerging in environments without sacrificing functionality, CommVault OnePass was developed. CommVault OnePass converges protection, archiving, and reporting operations into a single job as a means of maximizing efficiency and minimizing impact on production servers. During a OnePass operation, the dataset in its full form factor is only touched once during an initial full backup operation. Analysis of the data is performed on the media agent, and data that has established archiving rules will have their objects replaced with stubs on the production system. Not only does OnePass reduce the burden on the production server, it also serves to minimize the back-end infrastructure associated with these varied functions. OnePass reduces complexity and the potential for issues in data management operations. This graphic depicts the basic process that occurs with CommVault OnePass operations. First, the file system will be scanned. Next, the files eligible for processing will be picked. Those files will then be copied to the content store. At this point, the indexing operation will take place, as well as the analysis of that data for later reporting purposes. On the file system of origination, the files which were copied to the content store will now be stubbed, and a backup operation to protect those stubs will transpire. It is important to note that only incremental and synthetic full backups may be conducted with OnePass operations, as they are required for pruning and data aging operations. Some of the benefits of OnePass are highlighted here. Optimized scan mode can reduce the time to scan systems from hours to minutes on supported systems. Only a single full protection is performed. All jobs thereafter are incremental only. This allows you to scale to massive data sets while still effectively protecting the data within backup windows. You can define rules in order to archive data. Once done, the next incremental job will replace the original files with stubs to reclaim primary storage. Since this data may have already been protected, no additional data movement or storage is needed. CommVault Content Store features can then be leveraged. You may create file-level analytic reports, content index the data, or search using a variety of portals. NDMP for NAS generally provides the fastest and most efficient way to move data to tape. However, NDMP does have its limitations and challenges when meeting modern data management requirements. NDMP is a single-threaded protocol that was designed over a decade ago. It basically does a blind, block-based backup of a filer. It is often a pain point for customers in the enterprise that manifests itself during the scan phase of a job, which can take a considerable amount of time and generally falls apart at scale. NDMP also does not provide any inbuilt archiving functionality, and would require that the data be touched twice to achieve that. CommVault OnePass for NAS and non-NDMP file servers addresses these challenges, providing the capability to rapidly protect data on a filer using the CIFS or NFS protocol. In addition, the OnePass agent allows for both data protection, archival, and analytics in a single operation. The filer can be configured for NDMP or the file share backup through our two-way pseudo NAS client, meaning we get access to multi-threaded scans, meaning much faster job completion, and the non-tape format allows for modern technologies like deduplication, dash copy, incremental forever, and cloud-based backup targets to be leveraged. CommVault SharePoint Storage Manager helps customers address many of the challenges associated with storing content within SharePoint. Content uploaded into Microsoft SharePoint is stored within a content database on a Microsoft SQL server. As more content is added, the database becomes increasingly difficult to protect and recover. Bloated content databases also adversely affect performance. While it is possible to store large files in SQL Server databases, it is not necessarily efficient. Moreover, large files stored within SQL databases do not perform well when being accessed and updated by the end users. Customers need an efficient method of storing large files in SharePoint without bloating the SQL database and degrading the end user experience. CommVault Storage Manager for SharePoint leverages SQL Server Remote Blob Storage Technology, or RBS, and OnePass to externalize large files from the SQL content databases to a file system location, optimizing SQL storage and improving SharePoint performance. With integrated data protection and archiving, the Storage Manager solution provides SharePoint customers with an efficient and flexible remote blob storage platform they can be confident in. In this section, we will provide an introduction into the CommVault Exchange Mailbox Agent. The CommVault Exchange Mailbox Agent is a comprehensive solution that incorporates separate data collection, so-called archiving, cleanup operations or stubbing, and email retention management. Configuration is simplified through a single unified client entity that provides powerful user-level control through a flexible, policy-based architecture. Depending on the configuration deployed, archived messages are available for quick and easy retrieval by administrators, end users, and compliance personnel. For the user mailbox, cleanup operations remove old messages on the production storage and optionally create stubs. These stubs point to the messages that were moved as part of the archiving and cleanup operations. The Exchange Mailbox Agent utilizes an index-driven retention based on message received time, and therefore no synthetic fulls are required. The solution provides a powerful scale-out architecture that can utilize multiple mailbox proxies to help overcome some of the limitations of the traditional Exchange MAPI protocol. The journal mailbox for the Exchange Mailbox Agent works in conjunction with the Exchange journaling feature to capture all incoming and outgoing messages for compliance purposes. A cleanup operation removes journaled messages from the Exchange server and archives them to the content store, where they are stored and retained based on the defined policies set by the administrator. An alternative option to performing journaling operations is using the CommVault Content Store Mailbox feature. The Content Store Mailbox server is an SMTP gateway and provides the external recipient to where all messages are journaled and stored. The archive and cleanup operations delete the contents of the journal mailbox on the Content Store Mailbox server instead of Exchange. This means that there are no additional Exchange components required, which is extremely useful for customers running Exchange Office 365. Now let's discuss CommVault Edge endpoint protection. there are many challenges associated with the protection of end-user data. The security and criticality of data that an end user is generating is not necessarily at the forefront of their concerns while they are working. Data is more and more often being stored in repositories outside of the organization, such as in file synchronization services like Dropbox or Google Drive. Many of these file repositories or sync and share offerings do not provide true data protection functionality. And the security of the transmission of the data between laptops and an organization's data center is often an afterthought. A bring-your-own-device culture has emerged with consumers utilizing multiple platforms to create, access, and share information. With so many disparate endpoints and repositories, it is more challenging than ever for organizations and their employees to efficiently locate the data that they need, and also make it accessible to others to collaborate on. CommVault Edge endpoint protection technology is designed to provide organizations the assured protection of the remote data assets in their organization as a component in a comprehensive data management strategy. With CommVault software, the protection of laptops and desktops in an environment adheres to common organizational policies, improves governance, and also allows organizations to be aware of the data that is resident on edge device systems, as well as search across that data. It also has the ability to secure mobile devices with encryption, secure erase, geolocation, and remote wipe functions. It also provides end users the flexibility, convenience, and ease of use they have grown to demand with regards to their data. By eliminating complexity and providing end users the capacity to access their data anytime, anywhere, on any device, it accommodates both organizational needs as well as end-user demand for convenience through access and collaboration. Here we see how CommVault Endpoint Data Protection leverages Content Store at the core to provide a scalable architecture for Internet-based backups of laptops and desktops. Endpoint Backup offers the following key features: quick and automated backups, seamless backups using automatic schedules based on network connectivity, improved resource utilization. Deduplication technology coupled with intelligent backup scheduling dramatically improves the ability to protect distributed data with optimized disk resources. Network optimized backups. Backups over any network, LAN, WAN, or VPN with dynamic bandwidth throttling. Anytime, anywhere access. Instant self-service access of data using any web browser or the mobile CommVault app. Integrated security features. Full encryption at all stages and secured network access used together for data security. Automated customization based on business rules. Ability to configure additional settings such as encryption, retention policies, and content indexing before performing the backups. In this module, we describe some of the key features and functionality provided by CommVault software surrounding data protection. These included CommVault's deep integration with applications and its capabilities in protecting even the most complex applications. CommVault's embedded deduplication capabilities, including the capability to perform both source and target-side deduplication in an environment, as well as to replicate data in its deduplicated form factor with dash copy technology. Our advanced capabilities to protect virtualized environments with our virtual server agent, IntelliSnap functionality, which allows organizations to leverage hardware-based snapshots as a tool in an overall data management solution, CommVault OnePass functionality for file systems, which combines backup, archive, and reporting into a single process, the CommVault Exchange Mailbox Agent for message-level protection, archiving, and retention that is simple to manage and inherently scalable. as well as CommVault's capabilities in protecting remote user data with our CommVault endpoint protection technologies. We hope that this module has provided you a core understanding of these areas and the capability to express some of the key technologies that set CommVault software apart.